In this video, we shall look at an example of estimating the area below the curve using the Riemann sum. And in particular, we want to look at the function f of x is equals to x squared plus x plus 1 from x is equals to 0 up to x is equals to 4 using 4 subintervals. So ideally, the graph will look like this, and we have 4 subintervals, 1, 2, 3, and 4. We want to use the left endpoints, the right endpoints, and the middle ordinate. And remember that the Riemann sum says that area is approximately the summation of all f of x star I times delta x, where I is from 1 to n. In other words, it is the summation of the areas of all the subintervals. Now, if you look at the first one here, the first subinterval, the end point is at x is equals to 0. X is equals to 0. This is the end point. X is equals to 0. And in particular, the left end point. X is equals to 0. So at x is equals to 0, that will be our height. It will be our x star 1. X star 1. Remember, in a previous video when we were introducing the Riemann sum, we said the x star should be any point in this interval. It can be the end, the extreme left end point, and the extreme right end point. So for the left end point is at x is equals to 0. So f of 0 will be 1. F of 0, if you replace x with 0, you will be left with 1. So the height of this first rectangle here is 1. And therefore, the area will be the height 1 times the width. Remember, the width is uniform, and it is delta x, and it is equals to 1. So the area of the first subinterval will be equals to 1. The second subinterval, the left end point is at x is equals to 1. X is equals to 1. This is the left end point. And therefore, f of 1 will give us the height for the second subinterval. F of 1 will be 1 squared, which is 1, plus 1, plus 1, which is 3. So the height of this rectangle is 3 times the width, give us 3 times 1, plus the next subinterval, the left end point is at x is equals to 2. So we have this rectangle with the height f of 3, height f of 3, and f of 3 means that you replace, not f of 3, sorry, f of 2, you replace x with 2, 2 squared plus 2 plus 1, and this will give you 7. So the height of this rectangle is 7, and 7 times 1 give us 7. And finally, the last subinterval, the left end point is at x is equals to 3, and therefore the height of this subinterval will be f of 3, and f of 3 will be the same as 3 squared plus 3 plus 1, and this is 9 plus 3 plus 1 is 13, and therefore the area of this rectangle will be 13 times 1 is 13, and this will give you 24 square units. Note that sometimes we can even draw the table, because we know the heights at x is equals to 1, 0, 1, 2, and 3, then the height f of x at 0 will be 1, at 1 we have seen is 3, f of 2 is 7, f of 3 is 13, and since the interval is 1, then we can just add this and get that the area is 24 square units. Note that in this particular example, we are omitting a lot of space that is below the curve. We have not counted this. This is not part of our calculation, and therefore we have an underestimate of the area, And in the next video, we shall look at the right endpoints and see how it compares with the left endpoint.